We're live. Welcome back to Thursdays with me. It's July 28th. Seems like July went by pretty fast, but we got some more coordinate geometry. We just talked about the whole rule deal, so let's jump into it. Again, here's the copyright notice, just so that it shows on the recording. These are all going to be from GMAC's free GMAC prep software, except for the ones that are ours. And I will tell you which ones those are. So, okay. Let's do one. Let's do probably more about this one. Right here. This one is ours. This one is not a GMAC prep problem. Okay. Here is, remember, here's where you indicate your multiple choice answers. I'll give you a little bit of time to work on that. Go for it. Okay, there's not a lot of answers to this question. There's only about 9 of you have answered it out of 31 people here. So remember, this is a very good time to bring this up. Remember what time management of this test actually means. It doesn't mean minutes and seconds. It means if you are stuck, then stop what you're doing. And if you're not stuck, then keep going. It's actually all it is. Well, really it's 2 things, but that's one of them. I mean, the time management is, might as well just write it. I mean, just remember that time management in this test is basically boils down to 2 very simple principles. The first thing is, if you're actually stuck, then stop doing what you're doing. And the second principle is, when it's time to guess, just guess. As opposed to waiting like 10 or 15 more seconds before you guess. That's the other thing that people do, which adds up to, because there's a lot of guessing on this test. Like out of 37 quant problems, you're pretty easily going to be guessing at least like 15 of them. So that's going to add up to a lot of time. Like as soon as you realize that you have to make a guess, you have to just make one. 0 seconds should pass in between realizing I have to make a guess and actually making one. This, I mean, remember, you're either making progress or you're not. There's no partial credit on these things. So it should be like driving somewhere where you either know where you are going or you don't know where you're going. There's no halfway there. If you think I'm kind of lost, that means you're lost. So only about half of you have answers to this thing. So I mean, answer choices. I mean, I could put letters next to them if that's what the problem is. These are the choices. Okay, so I'll give you like 20 or 30 seconds, but you got to pick something, guys. Yeah, we still have non-answers from Ankit, Gurpreet, Derek, Manfredi, Naveen, S, and Stewart. So you should pick something. Okay, let's talk about it. People are kind of all over the place on this, but there are significant numbers of people picking actually every answer choice. So, but let's talk about it. So notice the functional word here in the question is could. Like what does this mean that we want to do? Like when the question says which of these could, Is that, I mean, this is kind of an open-ended question for sure, but does that bring any points of strategy to anybody's mind? Does that make you think of anything you could throw at this? Maybe you could try. But does it make you, yeah, testing cases is a good thing to think about. One thing that this should kind of put you off on is trying to like solve stuff algebraically, because remember about this test, I mean, this problem is ours and not theirs, but we use language in the problems in the same way that they do. They don't use language in ways that are misleading. Meaning, like, if you, as another example, if the question says, what is approximately blah, 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 the answer is not going to be something like exactly 6. It's going to be an approximation. They're not going to kid you like that. Same thing, if it says could, then it really is could, meaning, like, the answer is not going to be must. And it's not, so either it's going to be one of several cases, or it's not going to be something that you can solve for explicitly. At least not uniquely. I mean, if you can solve this at all, then it'll be one of several cases. You'll get multiple possibilities, only one of which will actually correspond to an answer. Okay, so there's that, but then testing cases is also a possibility. I mean, this is random A, B not equal to 0, so you can just like throw A and B at it. Because like this is pretty much, like, if you look at this right here, this is pretty much not even a restriction at all. I mean, this is anything as long as they're not 0. Any two numbers. So, but again, the difference, there's another, it's kind of like if you're going to solve it using a solving process, you have to be aware that there's going to be multiple solutions, some of which are dead ends. If you can do smart numbers here, but you need to realize that unlike typical smart numbers, your first choice of numbers may not actually solve the problem. So you can also use smart numbers, but you have to realize that you might come up empty. Your first choice or choices of numbers may not work for any of the choices. So what won't happen is you getting 2 correct answers. That's not going to be a thing. But you should be aware that because this is a could question, there will be numbers that are just not going to fly. But let's try that first. Let's just throw numbers at it. See what we can do. Let's try this. So somebody give me the first kind of set of coordinates that you would think to try here. You probably try something like 1, 1 first, or maybe like 1, 2. And then Gabrielle's got some negatives. We can try that, right? So sure. So like let's try this. 1, 1. Let's not use the same number twice, because then, I mean, if you look at these answer choices, it's probably pretty clear that that's a bad idea. Because if you use 1 and 1, then choice C and choice D are the same, and also choice A and B are the same too. Those are both these would both be -1, -1, and these would also be 1, -1. So, but let's try. Sure, let's try A and B equals 1, 2. Okay, so A is 1 and B is 2. So then the question becomes which is in the same quadrant. That's in the first quadrant. So 2 positive. You don't really have to know the numbers of the quadrants, by the way. I mean, as long as you know which quadrant you're talking about. I mean, it's first, second, third, fourth, but you don't have to actually know that. You're not responsible for that. So I'm just using that because I have to talk about it out loud. But this is the quadrant. So the question becomes any other points in this quadrant. But if you look at these choices, none of them are, right? Because all the answer choices have negative numbers in them. So unfortunately, this does not fly. So let's try the numbers that Gabriella said. Let's try AB is -2, 3. Okay. So in this case, A is -2, B is 3. So that point is in it's actually the fourth quadrant, but again, you're not really responsible for the numbering of the quadrants, as long as you know that it's visually this quadrant, second quadrant. Just kidding. -2 x coordinate, +3 y coordinate. So that's the second quadrant. Okay. Any other points in the second quadrant? Well, and again, if you got to write this stuff down on the paper. I mean, even such a thing as trying to juggle this in your head and mentally plug it into these choices will definitely get in your way here. So don't do it. Choice A is the opposite of B, so that's -3. And the opposite A is +2. That's the same quadrant. We should plug in the others. With smart numbers, you could technically have coincidental answers, so you should not take very long to plug in their choices. We should just see. But B minus A is +2, and minus B is -3. That's not the right quadrant. C, the opposite of B is 3, and then the opposite of A is 2. So that's not the right quadrant. D, A is -2, and opposite of B is -3. No. And then E minus B is -3, and A is -2. Nope. So we're done. It's A. Look at that. Let's see. Any questions about that? What is we don't difficulty level? We're not a thing that you should ever think about on this test. Totally useless to ever think about that. I mean, in fact, if you think about it, the fact that you are asking about that is proof that it's useless to think about it, because you will have no idea what it is. So there's no point in distracting yourself with parameters that you can't determine. There's a problem on the screen, and that problem is the whole world. And it's just you and the problem. I mean, even if somebody told you a difficulty parameter, it's not like that would help you. So don't ever worry about that. Okay, as far as a theory-based method, I mean, what is the actual theory here? Like, what property of numbers is pretty clearly the only property that's relevant here? Tell me in the chat. Like, what if we're not going to plug smart numbers in? Then what about these numbers? Because there's clearly no algebra that you can do here. Yeah, it's a sign issue, right? So like what the theory here is just going to be testing signs. So it still boils down to basically testing cases, but you just have to test different combinations of signs until one of the choices works. So sure. I mean, what you should do is you should organize it. So, like, you would want to make a table on your paper that just has like 5 rows for these 5 choices, and then you're just gonna plug them in. You're gonna pick signs for A and B, and then just see how this turns out. So positive is probably what you want to try first. It just makes sense. So if A is positive and B is also positive, then the goal would be to have it in the same quadrant as that. The goal would be to have it in the quadrant where everybody is positive. That's the goal. That's what we want to try for. So this is minus minus. This is also minus minus. This is plus minus. This is plus minus. And this is minus plus. So none of those work. So then you would just try another combination of signs. Sure, right? Let's say that A is positive and B is negative. So then the goal is to be in the same quadrant as the original point. So the goal is going to be to end up in the quadrant where it's positive and negative. And again, you should be writing all of this down. You should not be trying to retain this in your head. Like, I mean, that's the only reason some people got this wrong, I'm sure, is that they were trying to keep too much information in their head. I mean, don't try to hold this in your head while you're doing the work. That's a terrible idea. So, okay, if B is negative, then minus B is positive. And if A is positive and minus A is negative, that works. And we can still try the other choices. It won't take long just to check on our work, right? But if A is positive, then minus A is negative. And if B is negative, then minus B is actually positive. So now B is negative and minus A is the opposite of positive, so that's also negative. A is positive and minus B is the opposite of negative, so that's also positive. And minus B is positive and A is positive. So no, it's just A and we're done. Good times. I think it also works if you use negative for A and positive for B, I think. But you can always investigate that on your own. Okay. Yeah, a couple people are messaging and saying, yeah, it worked. Yeah, I think if they're after scientists, that works out. Cool. Neato problem. I mean, again, this problem is like 10% theory and at least 90% organization, right? Because there's no hard steps here. I mean, if you look at this work, there's no leaps of insight or logic. I mean, you're literally just reading the directions and putting what they say into a chart. The same thing if you do this. What if people have difficulty with this problem, it's just because they're trying to keep too much stuff in their head and not write enough stuff down. Like you want to write down the conditions that you're imposing on A and B. You want to write the goal. Anything. I mean, don't forget my kind of number 1 rule of GMAT success here, which is my number 1 rule for success on this exam, which is if you ever have to remember something while doing something else, you're not writing enough stuff down. Period. End of story. It's not really arguable. I mean, write down everything that you can. Because it only takes an extra second or two to write that stuff down. And it'll be faster, too. That's the other thing. The more stuff you write down, the faster you will get through these problems. And that's, you know, 'cause people are like, oh, I'm afraid it'll take too much time. No, 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 it won't. I mean, the more organization you have, the more efficiently you will get through these things. Because if you don't have this written here, then you'll take much longer trying to juggle that in your head. Yours could be, so as soon as you find a case, you're done. The question in the chat. I mean, you don't have to keep going. I mean, it could be as soon as it matches anything, you're finished. So, yep. Okay. Any other questions? No, move on to another one. Taylor's got some text in the text box. Taylor, are you actually typing the question? If not, then okay. Let's move on with our lives. How about? Oh, there's one. This one's a good time for everybody. This one's also us. Okay. No, that's where your multiple choice answers are at. Go for it. I need to actually no, I don't need to do that. Never mind. Problem's fine. Okay, at this point, it seems unlikely that you are still making progress, that it's actually progress. Remember what time management is and isn't on this task. It's time management is just admit when you're stuck and don't keep doing work that's not work. So, yeah, let's pick something, guys. Let's see. It's mostly the usual suspects here: Ankit, Argupta, Deep, Derek, Manfredi, Naveen, Nikita, and S. And they're almost exactly the same people who didn't answer last time. Remember, that's skill number one that you need on this test, is the ability to recognize when you are stuck and to quit. If you don't have that, then don't do anything until you have it. That's going to underlie everything you do. And make sure you pick an answer choice, guys. If it helps, there's 25 answers right now, and exactly 5 of them are correct. So that's literally equivalent to random guessing. So if you have to make a random guess, kind of what everybody else is doing too. Okay, the people who are not answering this question are apparently not alive. Okay, what I want to do is talk about how you can approach statement 1. Because again, I feel like people's biggest issue on this test is that they are basically married to things like algebra and textbook methods, and they just don't try other stuff at all. Like, how else can you investigate statement 1 if you can't figure out what to do with the A, B, C, and D? There may be some cute things you can do with A, B, C, and D, but yeah, you just try testing cases, right? So what I'm going to do is I'm going to clear out your answers in a sec, and I want you guys to try this problem again. But first, let's set up the work for that together for testing cases here. So try, because I mean, you can just make up random numbers such that AD equals BC. It's pretty easy to make numbers that do that. So this is a pretty ideal situation for testing cases. And then just what you're going to do is you're going to find the intercept of the line that contains this point. So testing cases for statement 1. I mean, don't do it in the chat, guys. Don't do it. So, okay, I'm going to clear out your answers, but let's set this up. I mean, you're going to pick A, B, C, D, right? And then once you have those, you're just going to find the point A, B, and C, D. I mean, you do have to obey that condition. You have to obey the condition that AD equals BC. So that's got to be a thing. So write that down. And then once you have those, you should say, okay, what is point A, B? And what is point C, D? Don't do it in the chat box, guys. Don't do it. Let's see. Okay. A, B. I mean, like, actually do this work on your paper. See what happens. And then intercept of the line that contains them. Try it, guys. Do another shot. Statement 2 is not as easy to pick cases for because that's kind of a more complicated looking condition. But do this on your paper, you'll see. And then I'll give you a minute or so to give this a shot. Yeah, it's a data efficiency problem. I mean, I'm not sure I understand the question in the chat box. I mean, the way that you determine whether the information is sufficient is by testing the cases. So, I'm not really following the question. Make sure that you do, like when you do this, make sure that you are crystal clear on what the goals are here. So, again, don't write outcomes in the chat box, guys. Don't do it. Make sure you pick the answers that are in the answer area. So, okay, go ahead and pick an answer again, please. Your original answers are all cleared out, so if you're going to pick the same answer you picked the first time, you should do it again. But only about 20% of you were right the first time. So I'm going to pick a choice here. The other thing about this test is that they don't ask unreasonable, crazy things of you. So, like if you look at these two statements together, do you think they're going to ask you to combine these? Do these look like the kind of things that you could conveniently combine with each other? Yeah, not at all, right? I mean, how would you even do that? So, I mean, that's something you can even look at that, right? When you go back through problems you've already done, like you'll notice that if and when you ever had to combine the statements, you should always find that it's pretty straightforward how to combine them. So if you see statements like these where there's like literally no obvious way to put them together, then you probably just don't ever have to put them together. Keep it in mind. I mean, they're not going to be super crazy like that. Okay. Make sure you pick a choice, guys. Only about half of you have one. People are doing a lot better than before. So good. It means the testing case is working. But pick something. I mean, okay, these are obviously not straightforward statements in any sense. So it should be clear that this is not a C-trap. But if you're talking in general, then sure, you should be aware that's the thing. Okay, everybody, the next 10 seconds or so, everybody should pick a choice to this. I mean, remember the single biggest skill you have to have on this test is like disengage, walk away, pick a gas. So you should pick one. There's still about 10 or 15 of you who haven't picked a choice. And your choice, guys. Yeah. Okay. I remember, because if you do that even once or twice, if you stare at the screen and don't pick a guess, then it's going to have an adverse impact. I mean, you probably won't finish. The only thing you need that has to be sort of close to perfect on this test is just leaving stuff. You shouldn't have patience on this test. You shouldn't have any patience. You shouldn't have any perseverance. Because they're not things that you should have. Okay. Let's talk about it. I mean, let's just pick some numbers that do this. Like AD equals BC. Alright, so like Anaya says 3, 6, and 2, 4. Because 3 times 4 is 2 times 6. Sure, right? 3 times 4. Now again, I mean, what you don't want to do is put them in the order A, B, C, D right now because you want AD to equal BC, so don't make this hard for yourself. I mean, write it in this order first. And then, okay, that's A and that's D, and that's B and that's C. Aha. I mean, just the more you write, the better off you are here. So A is 3, B is 2, C is 6, and D is 4. I've seen people miss this problem because they just switch up what B and D are or something. And you know, if that happens, then it happens because you're trying to do too much stuff in your head. Don't do it. Okay, so the point AB with those numbers is 3, 2. And the point CD is 6, 4. I mean, you might recognize that 6, 4 is just twice as much as 3, 2. I mean, if you had to find an equation in a line or something, then you shouldn't have to. I mean, the point is that you should notice that those numbers are multiples of each other. So if these are coordinate axes, then what the situation is going to look like is that's 3, 2, and that's 6, 4. is just going to be twice as far out in exactly the same direction. So this is going to be a line that goes through the origin. Because you're scaling it up times 2, basically. So it's going to look like that. Smiley faces, that makes sense. If you can see that this is going to go through 0, 0 without having to do a bunch of elaborate algebra calculations. And that's another thing about this test. I mean, this test will not put you through this full battery of steps that a high school algebra problem might. So if you think you have to do, like, I have to find the slope and then, like, dig up the equation of a line, I mean, if you can do that fast enough, you can do it. But you will never have to do that much busy work. That's not the point of this test. So the intercept is 0, 0. All right, so remember what not sufficient when you test cases is if you can get a different outcome now, then that's not sufficient. If we just keep ending up with 0, 0 over again, so if we can get a different outcome, 2 different outcomes, that's not sufficient. Change that typo. We get 2 different outcomes. You don't even get to the point of combining them, so that's not fair. I mean, you don't combine the statements in this problem. Also, if you ever think, oh, I just have a line, you should know better than that. I mean, perhaps you are brand new to this whole game, but you should, number one, you should realize that would be way too easy for this test. You should check out in the Thursday session archive. You should look for this phrase because if you're using reasoning like that and not immediately rejecting that reasoning, then you are going to get a lot of problems wrong on this test. And on top of the fact that you shouldn't even be combining the statements in the first place. That's another thing. I mean, if you're new to this, that'll stop happening. But you don't combine them unless they're both insufficient. So that's not what happens here. Okay, and we can also, I mean, we can pick, Tashin says 3, 2. We can have like 3 times -2. Sure. So -2 times 3. So then in that case, that's A and D, and that's B and C. So with those numbers, A is -3, B is -2, C is 3, and D is 2. So this point is -3, -2. And this point is 3, 2. So that 0, 0 is exactly halfway between those. Same thing. If we look for one more set of numbers, yeah, like 1 times 7 is 7 times 1. We could do. Okay, so A is 1, B is 7, C is 7. Those are the wrong letters. That's A, D, B, C. Okay, so A and B are 1 and 7, and C and D are also 1 and 7. Those are not the same point. They're not allowed to be the same point. So this doesn't count. But we can just multiply the right-hand pair by 2 or something. So we can do 14 times. We can do 14 times 1 and 2 times 7. All right, with those numbers, A is 2, B is 14, C is 1, and D is 7. Okay, and then you see what's happening here. It's pretty clear, right? You have the point 2, 14, and you have the point 1, 7. Taylor, if you were here like 5 minutes ago, we did that. We actually did draw it. We drew it right on the screen. Yes, you can draw it again. I mean, if you have, the point again with these two numbers is that this is twice as much as that. This is just twice as far out as that is. So if you graph these, 1, 7 is going to be over 1 up 7, and like this one right here. And then 2, 14 is going to just be twice as far out in exactly the same direction. And that's going to go through the origin again. And you're going to keep getting multiples. Every time you do this, you're just going to keep getting multiples of the same numbers. You're welcome. So you're not going to wind up with any intercept other than 0, 0. So this is sufficient. I mean, you can do this with the algebraic variables, but you would have to do things that there's no obvious reason to do. Like you could, like for example, you can transform this product into A over B equals C over D, and then you could notice that the slopes are the same from 0, 0. But the problem is that there's nothing cueing you to do that. Like, if you did this, you would have to do this purely out of total randomness, which is no reason to expect you to do that. You find the intercept by just realizing that these points are multiples of each other. I mean, if you think about coordinates that are just multiples of other coordinates, that means you are the same direction from the origin. You're just farther. Yeah, like over 3 up 2, over 6 up 4. Like this is over 1 up 7, over 2 up 14. Those are going to be on the same. Those are going in the same direction. So if you realize that, which is just visualizing it, then you don't need to do any algebra to find the intercept. If you don't realize that, you're probably not visually thinking enough. I mean, if your first instinct here is just to throw a bunch of random numbers into a bunch of meaningless formulas, then you should do something about that. Because visuals are a pretty big deal here. So, but yeah, the intercept's going to be 0, 0 every time. So this is sufficient. Even 2, these points, and what do we know about these points? What do we know about the points M, N, and minus M, minus N? I mean, well, any 2 points can be on the same line. So that's true, but that's also true of any other 2 points. I mean, so you can tell me more about that. They don't necessarily lie in quadrants 1 and 4. I mean, for example, if M is maybe 1 and 3 anyway. If M is negative and N is positive, then they would actually be in quadrants 2 and 4. But these, what relationship do these points have visually on the plane? Again, you can test cases. If you need to test cases, just do it. Do it. I mean, again, the point is to always be doing stuff. Like if you don't have an immediate, like when you look at these 2 points that are given to you here, if you don't have an immediate, intuitive sense of what this is, then you should immediately start testing cases of it and get an intuition. But you should never just sit there and stare at something. Don't do it. You have no immediate intuition here. Just immediately start testing cases. So you can just pick M and N and then put these 2 points on a line and see what it looks like. There's nothing to be perpendicular to anything. There's only one line, guys. One line containing both points. So yeah, there we go. I mean, they're both going to be equal. But I mean, again, if you, like, let's say that M is 1 and N is 2. So then that means that the points 1 and 2 and -1, -2 are on the line. So if you just think about what that looks like, 1, 2 is going to be like somewhere here. And then -1, -2. Yeah, it's multiples again. In this case, it's actually opposite. So this is just going to be the same thing, but in the opposite direction. And it's going to look like that. It's going to go through 0, 0. I mean, if you try for negatives, it's going to switch to quadrants, but the points are in, but you're going to wind up with the same result. So that means that -5, 1, and +5, -1 are on the line. So, and why I don't know why you're still trying to combine the statement. Sorry, Tashi is doing that. I mean, these statements don't get combined ever. I mean, statement 1's already sufficient, so you know you're not going to combine them. So, Tashi, it looks like you're trying to do something with both statements, but you can't use both statements. We're not using both statements. We're using just this one. This one is, I mean, yeah, that's a waste of your time. I mean, when you're working with statement 2, you're just working with statement 2. When you're working with statement 1, you're working with statement 1. Alright. So this point right here is going to be something like that. And this point right here is going to be something like that. And the same relationship. And these are always going to be opposites. So I think I did that backwards. I did, didn't I? Yep, I did. Okay. This is what it's upside down. It's supposed to look like that. That's what it actually looks like. It looks like that. Okay. Second guy. Okay, sorry about that. Give me 15 seconds. You know, texting going on here. Okay, sorry about that. It's a little tech glitch. Okay, so this is always going to be, these are always going to be opposite coordinates. So always opposites. So always, the line will always go through 0, 0. Yeah. So that's also sufficient because you only have one intercept. So statement 1 was sufficient. Statement 2 is also. So they're each sufficient. That's D like that overall. Okay. Now let's see where there's a bunch of action happening in Gabriella, that explanation is like the entire workup that's on this page. So if that hopefully just makes sense. But in statement 2, you're going to get 2 points that are always opposites of each other. And if you draw a line between 2 points that are opposites, then you will that line will go through the origin. So Good. I'm not sure that I understand the question. I mean, MY, it seems like there's some sort of lack of understanding of what sufficient and not sufficient mean, like on a base level here. Not sufficient means that you can actually get two different outcomes out of this problem. So, like when we do this, again, unless you think of some magical algebraic transformation, which is not hinted at in the problem, this is kind of the only option you have left. So you just do it, and then if you can get two outcomes out of this, I mean, that's what not sufficient means. Not sufficient means that you can get two different outcomes out of the problem. So, I mean, if this is not 100.0000% crystal clear, then this just means that you got to revisit the very, very, very basics of data sufficiency, and do more testing cases too. Because, I mean, there are a lot of data sufficiency problems where the only way to solve them is to test cases. So this is an essential skill set. I mean, you have to be able to do this. But sufficient means that you can only get one outcome no matter what you try, and that's what happens here. Not sufficient means that two different outcomes can be gotten from testing different things. But you have to test different things. I mean, if you only tested one case, then you would think that everything was sufficient all the time on every problem. So, yeah. I mean, like, I think the kind of reasoning that I think you're using would make you think that every answer is always D. So that would be something would clearly be wrong there. But just make sure that you know what that is. Okay. Same thing here. If you also could have 0, 0 as M and N this time, but that would still have 0, 0 intercept. So there it is. All right. Are there any other questions? I mean, people asking next problem. I mean, impatience is not a virtue, guys. All right, all people are typing. Yeah, okay, you're right. This line doesn't even count because the slope is not positive. That's a good point. It actually doesn't matter because it's affected, but yes, you are absolutely correct. Thank you for pointing that out. So this means that this doesn't even count. Same logic, we're still going to get points that are the opposites of each other, but we only keep the ones that are going this way. So, how is it sufficient? Because there's only one answer to the question. The question is, where is the x-intercept? I mean, you don't care where the line is. There's a lot of different lines that are possible. But, and also remember how this works, guys. Like, if you get a data sufficiency problem, like if you see this problem and you expect to find a line, you have already lost that game. Like, when you see this, as soon as you see this question, I mean, you need to understand. And those videos about C-traps will help you here. You should search that in the page. But as soon as you see this question, you should realize that the goal is just the intercept. So you're not going to find the line. But you might find the intercept, even though there might be multiple lines. I mean, these are very goal-oriented problems. Don't forget that. Because that's the entire point of data sufficiency at the end of the day, is to be super goal-oriented. So, I mean, there are tons of lines possible for both statements, but they all go through 0, 0. Yeah, like if you, in this problem, if we just took this negative signs out, like if we if we made it -5 and -1, then those are your points. You get a different line. It's going to have a different slope than the first one did. But still going to go through the origin. So it's focused perfectly on the goal. If you're not solving for the correct goal, you're going to get it wrong. All right. Let's move on. Thank you for pointing that out, by the way. C and then AB. Let's do a problem. Let's do one more. Let's say this one right here. Okay, there you go. Remember where the multiple choice answers are. And we'll probably have to discuss this pretty fast, given the time that's left, but we'll do what we can. Give it a shot. Okay, we should be wrapping this thing up. Remember, the essence of time management is just honesty about, are you stuck or are you not stuck? Okay, let's start talking about this thing. So, first let's translate the question. I mean, what does it mean for a point to be on a line with a certain equation? Like this point, unlike the other coordinate problems in this session, this one is not really meaningfully about visual coordinates in any sense. I mean, like if you want to know whether a line with a certain equation contains a point, how do you tell? I mean, if these are all variables, it's a little bit weird. But if I said does the line y equals 5x minus 11 contain the point 3, 3. I mean, how would you test that? Yeah, you just throw it in there. I mean, you see if it works. Okay. So in this case, it doesn't because 3 is 5. That almost works, but not quite. So 3 equals 15 minus 11. No, that's not true. So the point's not on the line. So that's what we have to do here, right? I mean, in other words, you just plug this in and see if it works. So you just plug R in for X, and you just plug S in for Y. So, and then so you basically just have is S equal 3R plus 2. It's annoyingly abstract, but if that ever does happen, that's what you should do. You should just make an analogy between the weirdly annoying abstract problem and then some other problem that is much more concrete. That's how you cope with that sort of thing. If something is too annoyingly abstract, then just make an analogy to a simpler or more concrete form. With the same form, the same type of problem. Okay, so you plug it in, and that gives you is S equal to 3R plus 2. So that's what we're trying to do here. Is S equal to 3R plus 2. This is a yes/no question. So remember, we have a lot of sessions on this. You can also go to the session archive and look up data sufficiencies that are yes/no. But there's this device that we have been using for those. So but remember, with yes/no data sufficiencies, if you can make both of those outcomes happen, yes means S equals 3R plus 2. No would mean that S does not equal 3R plus 2. If both of these can happen, that's not sufficient. And if you're stuck with only one of them. So in the sessions that we have recorded on yes/no data sufficiencies, we introduced this device where you just write those two outcomes, and then you make spaces for checkboxes. So the yes outcome would be that you can make S equal to 3R plus 2. And the no outcome would mean that you can just get S to be anything other than 3R plus 2. And then you make columns for statement 1, statement 2, and then if you have to combine them, both. So again, this is a super awesome way of organizing any yes/no style data sufficiency. We do a lot of these in the videos on yes/no data sufficiencies, so feel free to peruse the archive and check those out by all means. So, but if you get those in a column, if you get check mark in any column, that's not sufficient. Okay, let's do it. So in statement 1, what if you had the simpler case? Like, what if you had something like this? What does this mean about X? Better yet, let me put a Y here. Someone tell me what this would mean about X and about Y. Do we know both of those? Yeah, a couple of you are writing this down as though those were both known at the same time. But if you think about it, you don't need to know both of those. I mean, to make this true, all you have to have is one of the items in the product has to be 0. So if you were given this statement, then you would know either X is 4, or Y is 6, or both. But they don't both have to be true. So if you look at these statements accordingly, right? I mean, this is 0 for statement 1, or this is 0, or both. Okay. So if 3R plus 2 minus S is 0, let's move that up there. That means that 3R plus 2 would equal S, but you got a second thing, right? Or 4R plus 9 is S, or both. So it doesn't have to be true that 3R plus 2 equals S, because you can just have 4R plus 9 as S instead. So the deal here, in other words, is that like if this case applies, then that's going to check off the top box. And if you have this case, then that's going to check off the bottom box. You can find specific numbers that do it if you want, but there's no reason to really do that, because you know there are lots of numbers that make S equal to 3R plus 2. And you also know there are lots of other numbers that make S equal to 4R plus 9. So there's no reason to have to actually choose numbers that do that. Smiley face if that makes sense. These color codes here, and also notice how the organization helps. I mean, if you don't have this written down somewhere, I don't even know how you would possibly remember these things were goals. Statement 2 is going to work in pretty much exactly the same way. Statement 2 is going to mean that either 4R minus 6 is S, or 3R plus 2 is S. So that's going to check off boxes. Let's color code that. So that's going to check off the top box. And if S is 4R minus 6, and they're not the same, then it'll check out the bottom box. So now we got to combine the statements. And what's the only way that both of these can be true? I mean, it's kind of, there's a lot happening here, but let's put these both in gray boxes. You have to make that true, and you also have to make that true. What's the only way that both of those can be true? Yeah, right? If you want to make both of these gray things true at the same time, because if you think about it, and this is actually super important, 4R plus 9 and 4R minus 6 cannot be the same number, because those are strictly 15 units apart. So it's impossible for these to be the same. That's important, because if that was 5R plus 9 and that was 4R minus 6, then it would actually change the entire outcome of this whole problem. But 4R plus 9, it can't be those at the same time, because those are 15 units apart. Like one of these is 15 more than the other one. So the only way that you can get these to be true is for S to actually equal 3R plus 2. So this is going to, like, if you're trying to make S not equal to 3R plus 2, the only way you could do that would be to make both of these statements true. But that's impossible, because you can't equal 4R plus 9. You can't be 9 more than something and 6 less than something at the same time. You know, this is like me being 9 years older than someone and 6 years younger than someone at the same time. It's not a thing. So in other words, what we showed is that it's impossible to check this bottom box. Because the only way that you could check that bottom box would be if you could somehow have both of those happen at the same time. You could only get this if it were possible to have s equals 4r plus 9 and s equals 4r minus 6 at the same time. And it's not. I mean, those cannot both be true at the same time. So, nope, you can't get that. That would mean sufficient. If you can prove that one of these two is impossible, then it's definitely sufficient. I mean, you know there will be cases of something. So, you're done. This is C, like cat. Cool stuff. Yeah, probably the biggest thing here is just because I mean these are annoying. It's a 3x plus 2 and the 4r plus 9 and stuff. But if you think in terms of x minus 4 and y minus 6, it's not that bad. So you would realize pretty quickly, okay, either x has to be 4 or y has to be 6. So then just it's this again. It's what we have up here. If something is too abstract, then just make it less abstract. Just think of an analogy that is easier to get your hands on. And then make an analogy to the more annoying thing. Cool. All right, we got to wrap this up. We're actually a few minutes over time already, so let's kill it. Well, all right, let's see. The next session is in, I think it's just 2 weeks from now, but let me just check that for sure. The next session is going to be, actually it is next week. It's August 4th. Same time too. It's going to be it's going to be at this 6 Pacific, 9 Eastern time again, which is 2 hours later than it normally is. And then after that, it's going to go back to being earlier again. So, but it is 1 week from now, not 2 weeks. Okay, thank you, ladies and gentlemen. Let's kill the recording. Good afternoon, good evening, good night, good luck.